to special topics, particle motion. This is on page 61. All right. All right. So for the next 2 days, we are all in on particle motion, all the physics stuff, all those things where I might say, here's the position, how do you find velocity? And you all would tell me. How do we find velocity if you know position? You're gonna find the derivative. Think calculus, don't think AP physics. Calculus only. Derivative position is velocity. What if I have acceleration and I want to get velocity? You're going to do an integral, you're going to do an antiderivative. What if I need to determine if speed is increasing? Speed increasing. Kaylin, what do you have to do? Acceleration is positive is not true. Speed is increasing. What has to be true for speed to be increasing? Abraham, what has to be true? Acceleration has to be positive and velocity has to be positive. That is halfway true. If velocity and acceleration are both positive, speed is increasing. The other halfway? If velocity is negative and acceleration is negative, speed is also increasing. Remember, the key was whenever both velocity and acceleration are positive, speed when both velocity and acceleration have the same sign, speed's increasing. If velocity and acceleration have different signs, speed's going to be decreasing. Okay. Last thing I want to do a quick review of is don't shout it out, don't embarrass yourself. What's the difference? Don't shout it out. Jose, I'm not going to call on you. Save your arm. What's the difference? Wait until at least 8 people can tell me what the difference is. I see 1, I see 2, I see 3, I see 4, I see 5, I see 6. What's the difference here? Ashley?
The first one is the change in position, the displacement.
Okay, love it. The first one is change in position. What was that other word that you just said?
Displacement.
Or the displacement. Those mean the same thing. And this guy down here?
It's the total distance.
It's your total distance traveled. All the friends are okay? Okay, just you've got to make sure that you understand the difference between these two. All right, so here's what we're going to do. I want to regroup you all by what month you were born in. There is a study that I read this summer that said some months have more like smart people born in them than others. And I want to see if my data and my experience with you all bears out this research. So you get together in a group with other people that have the same birth month. Go. These are your partners for the next day and a half.
March.
January over here.
Evelyn. Because they're pink.
June's over here.
Nobody likes fear. Who's in February? Because Jackie seems to be very alone.
I said it's December like
January.
January. Okay, gentlemen, what month? March?
Right here.
Oh, you all October. You know I'll here.
No. No one's like
He's not a dog. Here, boy. Here.
I'm a December.
Now you can't move at this point. Okay. Carlos, what month? June. Is Carlos the only June? Okay, Ashley, what month?
December.
December. What month?
September, April.
September and an April. Over here?
January, February.
January and February. March. Okay, so we've got October and October. Okay, can you and Carlos work together? Carlos, can I get you over here just so we've got like somebody to like engage with here? Okay, so according to the research that I read, the all the smartest people are born in the month of October. That happens to be the month that I was born in. The article had other things to say. I stopped reading after that. I was like, oh, clearly it's true. More presidents, more astronauts, more exotic dancers born in the month of October than any other month. Okay, so here's what you are going to be doing with your birth month friends. There are 13 statements at the top. These are all particle motion statements. I'm curious, do you know what to do when you see that statement, and can you match it with the stuff at the bottom? Ashley? Okay, I thought you were going to say, what about like people not born in October? Okay, page 61. There are 13 statements. You need to match them with the ones that are at the bottom. You only get to work in your groups. So for example, if a particle is moving to the right, take 10 seconds, look at those options at the bottom. A particle is moving to the right, what's the thing you know for sure? What is true if the particle is moving to the right? Look at those options. There's 13 statements, but I provided you with a whole lot more options at the bottom because that's how I roll. Need you to lock it in 3, 2, 1. What's the letter? Oh, that was really sad. Almost as sad as Avengers. Took the girls. Particle is moving to the right. That means your velocity is positive, greater than 0. So what letter? F. Okay, everybody knows how we're going to work this? My expectation is that 1 through 9 you're going to feel really good about. I'm just going to circulate while you do that, and I'll sign the signature cards from this weekend, or from Friday, sorry. 10 through 13 are going to push your thinking a little bit more. You've got 8 minutes total. See what you can do. He's not born in October.
Bro, I was at that same first though.
Cards.
I was just gonna say. Just know the other guy is
Oh, so then isn't it 4 cube?
Yeah, I mean, I was gonna tell you that.
All right, friends over here. Kaylin, come on.
I didn't get checks for
Thursday was the party. Friday you were absent. Okay, but you watched the video.
Yeah.
Okay. All right, Roberta. Oh, Jose, I'll be there in a second. Sorry, if you're not born in October, I'm not really interested. But okay, Roberta. Yep. Thanks, sir. Carlos. Thanks, sir. October 22nd. Apparently that's when like super smarties are supposed to. Yeah.
So for Fridays homework on Thursdays, the weekend.
Yeah.
Isn't it early?
Okay, Jose, I said party.
Happy.
All
Average, the particle look at x equals 0, and x of 0 equals 5. So this is a particle at 19.
Hey!
Oh, yeah, B, right?
We just talked about it.
The particle is looking at that position of particle at 19.
Pensaba. No hacemos nada.
It's positive and negative.
Yeah?
It's ice. If the particle is at rest, then I'm waiting for you to tell me.
I don't know, I already told you.
Not something. I can still leave my class.
You told me to do too, like, were you
There's a lot of like.
I think the particle of A
But you guys are different iterations.
So what I've done in the last 2 weeks, I did all of these special projects and sent it out to them. They watched the video.
That's different. Like the particle is different rays. There's particles going in different directions. There's rivers.
So I have a document overhead. They've already got all this in their packet. And so I go through please explain setup for them is like how you earn points, looking for all the things. So I just went around.
Yeah, and then
Forward, el viernes de hecho llego y pasar el otro.
No? What is it?
the integral of 8
Oh, and then exit.
What's the integral?
So 2, 0?
Particle A and B are determined by
Something.
x
Is it
raised to
displaced? Is it displaced?
¿Cómo vas a hacer?
Es como si alguien se te moviera y vas a estar feliz.
Feel good about the one so far?
How do you know if the average is
So far, so good. Keep going.
Oh.
Yeah. See, the spark was increasing, right?
Velocity should be 0.
The velocity has to be greater because that will increase. No,
Oh, yeah.
So I created a video. Anyway,
No.
special topics from the love to
No, you see how this is because we just said that they're the same size. He like and they different sizes.
I mean, I've heard it.
Should have read it. It's gonna be making sense to this.
Hey, that was good.
And just as a way to push my instruction, but then I can also share this with all of our calculus teachers. All of the calculus students. And we go from there. All right, friends, here we go. Okay, if particles move to the right, then velocity is going to be positive, so we already said that's F. Okay, speed of the particle is increasing, then B, velocity and acceleration have the same sign. Find the total distance traveled by the particle from time t equals a to t equals b, which one? O. That's going to be O, nice. To find the displacement of a particle from t equals a to t equals b? Q. Q, nice. To find the average velocity of a particle over the time interval a to b? A, right? It's that key word, that average. Average anything. You're going to integrate the anything from place to place, divide by the length of the interval. Nice. Let's see. A particle is located at x of 0 equals 5. The position of the particle at time t. L. This is a fundamental theorem of calculus question. You know the initial position. You want position later on. So that's FTC. Number
7.
Did I skip one? 7. If the velocity of a particle changes from increasing to decreasing, velocity change increasing to decreasing, what happens to acceleration? I changes from positive to negative because acceleration is derivative of velocity. 8, a particle is at rest. S, your velocity is equal to 0. Number 9, the velocities of particle A and B are determined by v sub A of t and v sub B of t respectively. If the particles are moving in different directions. Wait, one more time?
E.
Okay, if the particles are moving in different directions, like this way or this way, what happens in both cases, one of them's going to the right and one of them's going to the left, the velocities have to have different signs. You don't know which one's greater, but they're going this way or they're going that way, so that should be E. How many guys honestly get the first 9 right? Okay, 8 out of the first 9. I can deal with 8 out of 9. These are the questions. These are the things I want it to just be like automatic. You're like pop, 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 pop. Because oftentimes, what will happen on the AP exam, they'll do something like find the position, and if you write 5 plus the integral from 0 to t, v of t dt, even if you don't do anything else after that, you've already locked in a point because you're demonstrating like an understanding of the calculus physics connections. So I want to make sure these things are clear. Now 10 through 13, this is where the College Board starts to get mean, and so do I. They have done a lot of questions lately where now there's like 2 different particles. We've seen a couple of those. Things get weird. You might have some particle going left and right, and the other one's going up and down. There was one in your common assessment. Okay, number 10, velocities of A and B are determined by v sub A of t and v sub B of t respectively. If the speed of particle A is greater than the speed of particle B, what has to be true? D?
Okay.
D says v sub A of t. V sub A of t is greater than v sub B of t. Velocity of particle A is greater than the velocity of particle B. My statement was that the speed is greater. The way that you find speed involves taking the absolute value bars. Yes, I mean, and I got you, so that one is K. Number 11, the positions of particle A and particle B are determined by x sub A of t and x sub B of t respectively. 2 particles are in the same place. If they're in the same place, right, x sub A of t is equal to x sub B of t, but that's not one of the options. Which one gets you the same thing, though? If they're in the same place, that means that the distance between them, x sub A of t minus x sub B of t, is going to be equal to 0, and so that should be H. 12, the positions of particle A and B are determined by x sub A of t and x sub B of t respectively. The distance between the particles. Here's a particle. Here's a particle. How do I find distance? Distance should be, we're subtracting the 2, right? Why the absolute value bars? Why those absolute value bars? X sub A of t minus X sub B of t. Why do you have to have the absolute value bars? Distance cannot be negative. And depending on where the particles are when you do the subtraction, you might be subtracting them in the wrong order. So that's why it has to be X sub A of t minus X sub B of t, and you need the absolute value bars. That's the distance between the two particles. Evelyn, you okay? All right. So now that we've got that, the positions of particle A and particle B are determined by X sub A of t and X sub B of t respectively. The average distance between these from t equals 0 to t equals 4. P or R. What I want, this guy here is your distance expression, right? And what am I asking for in this last one? I want average distance. How do we find average anything? Average anything. Both options have the integral from 0 to 4 and the 1/4. This is your distance. I want the average of that distance. So it has to be R. If you pick P, what you're doing is you're looking at the difference between their velocities. So what you'd be finding is the average difference between their velocities. I want the average difference of their position. All right, so how many guys went 13 for 13? 12 out of 13. Okay, make sure you let me know later on when I sign the card, because that's like moving in a good direction. All right, we've got 21 minutes left. And what I've got for you, there are 8 multiple choice questions, so I'm looking on pages 64 and 65. There are 8 multiple choice questions. If you and your group of people can get 6 out of 8 right or more, that is a check plus in terms of the participation. If you can get 8 out of 8, that is a check double plus. I have not given out any check double pluses today. I would love to be able to give out a check double plus. I'm expecting the Octobers will of course get a check double plus because, you know, it's just your thing. So I'm thinking if you don't get 8 out of 8, it's a check minus. This is called differentiation. Get them all right or it's a loss. Should I go put the check minus over there already?
Talk this way.
Oh yeah, so this position on 64.
No habla tan perfecto. Está disponible.
This is a position graph, right?
So just A of T is positive, right? So that I can do it as B of T.
But the thing is,
So what is position the same as velocity?
And so there's training that they do in the summer, part of that training process.
We know that if we get started,
Then you would start.
and then
As a teacher with 140 kids, and you're instructing coach there to support people that feel better.
between that and that area. So all you have to find out from data point interval where the velocity. What? Before you do that.
Because you just move it over.
It's negative.
Somebody
Before you do that,
who doesn't have the certification,
you already have
secure your certification by the end of the year, then they'd say, very nice to see you, and they go, good luck.
So, all right, 3 to 4. So,
Okay,
so that gives you more.
This? Yes.
Which one is velocity?
Position, velocity, acceleration.
Discuss later after. C plus total distance.
Okay, so, but you already told me about this position, velocity, acceleration connection?
Yeah, it's
Okay, so let me,
Oh, yeah.
Can we get around
so Delia, this is partially for the friends at home, right? So you already said the velocity is negative. We know about this position, velocity, acceleration relationship. You said velocity is negative, so position has to be decreasing. Okay, and what else do we know? Acceleration is positive. So acceleration is positive, what do you know? You're at the very bottom of that link. What do we know about velocity? If acceleration is positive, velocity has to be increasing. And if the velocity is increasing, then your position has to be concave up. So you're looking for your position to be concave up and decreasing at the same time. Are you like early in November? Late September? Nice, nice, nice. Oh, yeah. See, I think you should thank me for this like double blessing of physics support that you're getting leading up to the physics exam. If you get any of these wrong, I'm going to tell. That's what you get. E-B. Looks like an E. There you go.
Velocity to acceleration. Right?
I can find it.
Right?
Yeah, of course you can find everything. Everything in your life is here.
Oh, that's
Oh, everyone.
You really took it. You took that confidence to your grad.
I don't like this one. Did you guys get this one before? I did this one. Good, keep going, keep going.
No saben de la I, de la U.
was no article. There's no research to support my claim. But being born in October, I am convinced that it's true. I've met people born in many of the other months. I have lots of evidence. And if my brother's watching, April is when the dummies were born. Right, but why are you using it? It's not initial position.
Velocity.
It's your initial velocity, right? So it's one of those situations where they gave you a starting velocity and then they want a velocity later on in the future. That's the key to no fundamental theorem calculus. I have this value, I need another one.
A, E, F, G.
¿Y la 4, profe?
Because it's Thursday, right?
So we're asking about speed decrease, right? What is that? What has to happen? What's true about velocity?
English will probably be better.
Sorry. Speed is decreasing, velocity and acceleration at different times. So given the velocity is positive, acceleration is negative, right? Well, if you don't have an acceleration graph, velocity. Acceleration is negative, what does velocity have to be doing? Acceleration is negative, velocity was. So you're looking for places where velocity is positive. And so that, not from 0 to 4, from J to K is a place where velocity is positive.
So you find out the derivative of
What's the next
it will be 2 cos 10. No, 5 10 we're right here. We're right here in the second ring. No, that's that. And then you guys are asking where that, right? So you look when the value is
You missed something.
Wouldn't just be this?
So a particle moves along the line so that its acceleration is given by that. So you have an acceleration expression. You know the velocity at time 0, you want the velocity at time 3. So they gave you, for the friends watching at home, this is number 4. So they gave you that the velocity at time 0 is it 5?
Yeah.
And they want the velocity at time 3. You know the initial velocity, you want this velocity later, how do you get it? The velocity at time 3 is your velocity at time 0. Finish it. Wait, plus what?
Integral.
You're going to have to do an integral. Velocity at time 3 equals velocity at time 0 plus your integral from 0 to 3. The derivative of your velocity. Right? This is your fundamental theorem of calculus.
So would it be the derivative?
Right. Well, that's how the fundamental theorem of calculus works. F of b equals f of a plus the integral of the derivative of f. I wrote derivative of velocity, but you have another name for this. Acceleration. But I wanted to write it that way so that you'd see why that works.
That's a good answer.
So we have to
That was awkward. Yep. Yes, indeed.
And I think there's what?
Acá se pegó Lolo. Güey. A la misma vez.
You got 160.
Whatever are you on?
No,
Okay.
6 to 1, that'll be 1.
But that's good. This is very
Yeah, 1 to 6.
I just wanted to. Josie, did you do it? Oh, I never.
Not the only ones that do it.
Who knows?
Bro,
Rebecca did do it. Yes. And I did it. Wow. That's a great.
She did that to me too.
Where y'all getting y'all numbers from? Really?
I wasn't asking you whenever.
Sad news, friends. We've only got 6 minutes.
you're already at 60, right?
Are you okay? Did you guys win on Saturday? Did you win on Saturday? Oh, I'm sorry. Is there anything else I can say to make you upset? I'll just keep asking about it. Okay.
That's what Jose is doing.
Jose's not that smart.
That's what a lot of people do.
I have a much healthier sense of where your boundaries are. Kevin, I have something for you. And it's over here.
You're the one who keeps saying
I'm just gonna see right.
Particle moves
That's what it is. That's what it is.
I was on worse.
How y'all coming?
Okay, that's
No. I probably got it wrong.
Indeed, sir. Indeed. Yes, sir.
is the
You need my hair. Lord Jesus Christ.
30. Mark moves on the apex. Todo desechado cada particle.
Creo que las 6
You never actually your setup is perfect. Well, once you, so what is the integration?
You will be
Are you the
Antiderivative.
Three
3t squared and then you plug in 1 3t squared. That's 4e.
so you find the antiderivative, right?
Okay, so
We are so happy.
T. 196. What? I'm confused. 3t squared.
Where'd that come
Thanks, brother.
Wait, what? I agree. It has to equal 0. That's the only thing you've written down that I don't know. Where did this cosine 2 pi t come from? Oh, it is? See, I was thinking that we probably needed a derivative of sine of
You
stuff.
plug these in again.
Oh.
Yeah.
And because this isn't 2 pi, this is 2 pi
Because
times
they
n.
know it's in
That has a derivative as well. Yes.
6 and 7.
We'll find out in just a moment. All right. So for all the good-looking kids in the room and everybody watching from home, here come the answers. Number 1 is E, number 2 is B, and number 3 is E. And I think from walking around, everybody had those. Okay. Number 4 is E. It was a tricky fundamental theorem of calculus question. Most popular wrong answer was D. Those are the people that did not include the initial condition. Number 5, super tricky one involving some trig. D for de Rosier. Number 6, Delia, what'd you get on this one? D21. Nice job. Number 7, D for dynamite. And number 8 is A. Did anybody get 8 out of 8? Okay, I didn't think so. 6 out of 8 or 7 out of 8? Okay, if you get 6 out of 8 or 7 out of 8 in a minute, I'm going to ask you to come on up and make sure I sign your card for a check plus. Everybody else is a check and a signature. 2 nights homework. Particle motion day 2. I will tell you it is a 30-minute video. It is 1 question. It is one of the meanest particle motion questions that I've seen so far. It was not an actual AP question. It was made up by somebody like me who likes writing questions. Tomorrow, where are we meeting? College Corner. Bring me the card so I can sign it, please. Oh, and progress monitor corrections, please leave those in the middle of the table. If you get 6 out of 8 or 7 out of 8, make sure I know so I can use the check slice. 7 out of 8.